So it's like the actual section. So there's notes in there, all the theorems in there, in the same order you get them. It's got some examples, but like, I don't mind the examples so much for this chapter, because it saves you time writing out proofs. Okay, because I'm just doing fill in the blank ones right now. So instead of you having to copy the entire thing, we can use the stuff that's in there for a little bit of the fill in the blank. But in the next couple chapters and beyond that, I just don't like most of the examples in there. I think they're too basic. So like they don't line up to the actual homework problems or test problems that you'll have. So I kind of go away from it. Now, if you want to keep using it so you don't have to write every little thing down, that's fine. Okay? But I'm just saying I'm probably, beyond this chapter, I'm probably not going to do too much in it. Okay? But we have it available, so some people like using it. Why I give them out. Okay? Now, the whole thing today, like the main goal, what you need to be able to do is be able to tell if two lines are parallel based on some angle measures given to you. Okay, that's the main thing. Okay, so that's like the focus of it. Most of the stuff that we're going to talk about, we covered yesterday. The difference between yesterday and today is yesterday we did problems where I told you there was two lines that were parallel and that made angles congruent or supplementary, where today it's going to be the same kind of information given to you. It's just now instead of me saying two lines are parallel, I'm going to say, are these two lines parallel? And I might have some angles marked congruent, or I'll have some numbers in there to add up to 180 or so on. Okay, now, you guys right now need to, and just remind you, right, that was everything we did yesterday. Okay? Now, what you guys need to do is, for this parallel line stuff, like proving lines parallel, okay, you need to kind of have a list out. You're going to make a list as to what the notes would be today. Not this stuff, this is from yesterday, this is just a reminder. Okay, and like I said, the main thing that's going to happen today is, yesterday I said L and M were parallel. Today I'm going to say, like, alternate exterior angles are congruent, therefore the lines are parallel kind of thing. It's the converse of what we did yesterday. But what you need to do is you're going to make a list. Okay, there's going to be, by the end of today, there's going to be 7 things you need to put on. Okay, so you got to give yourself enough room for it. The first 4 are going to be strictly these things. I'm just going to restate them a little differently than what we did yesterday. Okay, so you're kind of looking at it in the reverse order we would have done yesterday. Okay, so these are going to be the first 4 things you put on the list. All right, now, the way I'm going to do it, so you can title it just like it says up there, 7 ways to prove two lines are parallel. What this is going to do, the reason I want you to have it as a list, is you need to have, when you're doing homework or classwork or whatever, you need to have it out and just use it as a checklist. Where if you see any of the 7 things pop up on the diagram, that's enough information for you to say the two lines are parallel. Okay, so that's how you get to kind of use it. So first thing. Now, what I have in the regular words, not in the parentheses, is what you're looking for. So when it says, show that a pair of alternate interior angles are congruent, that means that, like on the picture somewhere, the diagram, you know, you'll have 2 angles that are alternate interior angles, and they'll be marked congruent. And they might have that picture there, and this might be called line A and B. And it'll say something like, based on the diagram, is there enough information to say A and B are parallel? And you would have to say, yeah, because this reason right here. They're alternate interior angles, they're congruent. Okay, so again, just like yesterday, the thing in parentheses, guys, that's your reasoning, right? Because you're focusing on trying to work with proofs and set them up. So one side is your statements, the other side is your reason. And I try and keep all the stuff in parentheses as your reason. And what you'll see, like I said, we're doing converse of what we did yesterday. So on the terms that we did yesterday, you're going to see the word converse. Okay, this only pops up if they're saying, are these lines parallel? Or if you're doing a problem that relies on trying to find out that two lines are parallel. Okay, if we were doing it the way we were yesterday, you wouldn't have the word converse on there. You'd have like congruency. That's the difference. So converse only pops up with proven lines parallel. Alright, so second thing would be alternate exterior angles. Like I said, these first four are just kind of repeating what we did yesterday. Okay, the only thing that I'm adding is the reasoning there, okay, making sure that you have that reason written out so that when you match it up today and as they explain or justify, that's what I'm looking for. Alright, so the other two that aren't up there yet would be, we did alternate interior, alternate exterior, so the other two would be corresponding one, and then the same side two. Okay? So as long as you see one of those properties pop up, then that's enough for you to say two lines are parallel. Okay, so those are the four main ways that you're going to look for. Like even if we're going to have three theorems here in a second that are in addition to this that you can use, but they mainly serve as shortcuts to these. Like these four are the ones you definitely must know, you need to be able to work with. The ones that are going to come after are just going to save you time in terms of a full explanation. Alright, so these are the necessary ones, the ones you better know. The ones afterwards are good to know, but if you forget them, you can always work around the problems with these right here. Okay, one way or another. There might be one theorem that's going to be hard to work around with. Okay, so I'm going to do just a couple quick examples. All right, and then in the companion thing, I think somewhere around page 68 in that student companion, I'm going to do like one or two problems in there before I give you a couple of classwork problems. Okay, but I'm going to do one up here first. It's not in the companion, like a couple problems, just so you can see what to expect. And then we'll do like one or two, and I think it's on 68. Yeah. And then I'll get a little classwork, at least to split it up. And then there's some theorems afterwards. Okay, so I'm going to move past this, guys. The list will pop back up at the end, so if you're like stopped writing, just understand that you're up to number 4. There's going to be a number 7, so leave yourself room for adding the other. Okay, so these up here, this would be a pretty basic kind of problem for what we're doing today. Like the diagram's there, there's only one transversal, there's only 2 lines that's intersecting. It's not making it more complex with other lines drawn through it, other intersections, nothing like that. And the question's just saying, look, based on what's there, and solely what's there, is there enough information given to say whether or not lines P and Q are parallel? All right, and I would say also, you know, if you're giving me a yes answer or a no answer, I want you to justify it, meaning you're looking for whatever's in the parentheses for your justification. Okay, so you just go through the checklist. I mean, we've got 4 things to look for. So for each one of them, we'll start over here. The angles that are given are 130 and 50. Do they fit any of the 4 that were given to you?
Yeah.
Or what? Okay, so they're the same side interior. So you go, okay, I know they're same side interior. What's the property that I want to go with the same side interior? I want them to do what?
Equal.
Yeah, they got to add up to 180. So you would go, okay, well, 130 plus 50, is that 180?
Yeah.
All right, so since those are 180 and they are same side interior, then you would say, yes, there's enough information, and your reasoning, guys, needs to be that same side interior converse. Okay, so I would expect, if I gave you this problem, to see like the yes answer and that part. I added more than really needed to be done, but I was just like, you know, if you want to read into other stuff. But those are at least the 2 things I'll be expecting. So all you're doing is, like I said, use those 4 things as like a checklist. If at least one of them pop up, that's enough for you to say that the lines are parallel. If none of them show up, then you can't. It'll be enough. Okay. The one in the middle, do you think that's a yes or no?
Yeah.
Yeah,
No.
why?
Alternate exterior.
Up in exterior, what comes after?
Converse.
Converse. Okay, and everyone's okay, right? X and X are equal to each other, correct? I don't need numbers there. Let's just say x equals x. Okay? So again, with this, all I need to see was the yes in the alternate exterior converse part. As long as I have that, that's enough. What about this one over here? What do you think? Yes or no?
Yeah.
I think yes. If you tell me yes, you gotta give me a justification why. Okay, but is vertical angles on that list?
No.
No. Right. So if it's not on that list, guys, just say no. There's nothing there for it. There's nothing saying this line here is actually drawn parallel. It could actually be going this direction. It's just not drawn the scale now. So if it's not on that list of 4 things, you have to put a no. Okay? So the only angles given to you right there are the vertical angles. That's not part of the list. So I can't use. It's not saying that they aren't parallel. I just don't have enough information to decide right now whether or not they are. Okay? All right, so on that page 68, guys, I'm going to go through 14 and 15 on there. All right, so if I was to actually keep using this thing, if they actually had good examples in there and I kept on with it, it'd be kind of like this, where the examples are just going to be they've got the stuff there already written out, so you don't have to rewrite it. It is going to probably be circling, fill in the blanks, that kind of stuff. You're not actually doing full problems in that. That's another reason I put it like that. Okay, but if I went through here, and it's says underline, or I'll do circle, it's going to be more obvious. But if I circle everything I need to complete the sentence, okay, and if you just read through it, is this first part, 6 and 7, is that given or is that what they want me to prove? Just read it real quick. Given, right? Okay, because it says right here, right? It says if 6 and 7, so I know that's my given. I didn't remember if, you kind of think hypothesis, so that's what I want there. And then if you look at the picture, here's 6, here's 7. Are they alternating or are they on the same side?
Same side.
Same
Side. They're both not on the exterior, they're both on the interior, so that's even that. This right here, I don't want you guys thinking in terms of postures. I want what was in the present. What kind of angles are 6 and 7? Like using the names we did yesterday. Corresponding. So this would be corresponding angles converse. Okay? And then for this one here, which lines are actually parallel? Is it A and B or is it L and M?
Element.
Okay, here's the thing with it. Remember I told you yesterday, if a line doesn't actually intersect with the angles we're looking at, like A, doesn't come anywhere close to these. It's way over here. So I really don't even care about A. It could cease to exist in this problem and it wouldn't change it one day. It wouldn't help it. Okay, so A really has nothing to do with this problem. So B is the answer there. All right, that's why this would be eliminated. You would eliminate that because of the fact that it doesn't intersect. Yeah, why?
Wait, so can you explain that?
We used to have backs in here.
I read the.
What?
What? We used to have backs in
What
here.
do you?
That's
Like
nice.
one or two that actually walked across the room.
Like you just walk?
Yeah, they walked.
Really?
Were you guys like just
That.
staring at them or something like just like?
There used to be bats in the room. They walked stuff.
The blind kind?
Yes.
Yeah, flying back. I don't know what that
Oh.
Okay, guys, hey. So I'm going to go through 15 now. All right, just for the purpose of, like I said, you're focusing more on writing the proofs now. Okay, so that means that the more that you can see of this, the better. Okay, in addition to what I suggested, you make a list with all the theorems and postulates on it. The more examples you have of these to pull from, the better off you'll be. Okay, proofs take time to learn how to do. You have to see examples, you have to see the process happen. You just don't do them. Okay, at least most people. All right, so this one here, if I fill in the blank, it says it right there, given 1 and 7. So 1's congruent to 7. Right? Got it. If I look at the picture, they're telling me here 1 and 3 are congruent. If I look at the picture, why are 1 and 3 congruent? What kind of angles are they?
Vertical.
These are vertical angles. Since it's a flow proof, there's always going to be a part where they say take these two statements, put them together and create a new one. If you look at this, do you remember the property that where I took two statements that look this way and put them together into a new one? That's transitive. That's transitive. And this is property of congruency. Okay. Now they're telling me to look for another pair of vertical angles. Give me a 7, so one vertical angle 7.
5.
5. And then finally, what do you think this is doing?
Alternate interior.
It's transitive, right? But we're doing it based on what's there, so this is going to be transitive again. Because it's taking these two right here. 7's the overlap. Remember, cross out that overlap, whatever's left over. It's transitive. What this is doing, I know 3 and 5 are alternate interior angles, and I would go right from the beginning and say they're congruent, based on what we did. But it kind of proves the theorems we did yesterday, what it is. All right? Okay, so what I want you guys to do, this is in geometry book, in your regular book. You can, if you want to put another name to it, you can, but I'm not going to show it. So guys, if you want to look in that little companion thing, it's on page 71 and 72 are all these theorems. If you want to write them a little different.
This is the fifth one, right, on the list?
Sure, you can do it. Doesn't matter.
Yeah, it is. Oh.
But you can have it.
Wait, so,
What do we call it?
Theorem 3A.
oh.
So here's the thing with this one. It's a very specific situation where you have to have one line that's perpendicular to two other ones. Okay? Like it has to be giving you to exactly like it. They have to say these are perpendicular for you to do this. Now again, you can kind of use what we already had up there, because if you look where those right angles are marked, there's the corresponding angles. Corresponding angles are congruent, the lines are parallel. So that's a way around this if you forget this theorem. All this theorem does is it saves you some steps in terms of an explanation. So if I did corresponding angles and I started with perpendicular, you would literally have to say these lines are perpendicular. That means they make right angles. Right angles are 90 degrees. All 90-degree angles are equal to each other. That means the angles are congruent, which means the lines are parallel. It's really wordy as opposed to me just going, oh yeah, they're parallel because of this theorem. It's a lot quicker. All right, so if you remember it, it's a good thing. Okay. The next one, again, very specific situation. You have to have 3 lines, okay, that are basically parallel to each other, and you're just kind of linking them together. If you want to relate this to something else, guys, it basically looks like transitive property. Okay, it's just doing it with parallel lines. If you want to think of it as transitive property with parallel lines, that's fine. Okay, it's got P and Q, like you have to be given P and Q, with Q and R being parallel. Use the overlap, and just like transitive, you take the overlap away, whatever you're left with also has to be parallel. You want to think of it as like a transitive property for parallel lines. Okay, so you should have these two added to the list at least. And guys, like on the list, if you want to write it out like the theorem, and then put the number in parentheses or something, that's fine. If you want to just write shorthand like theorem 3.7 means you have to have 3 lines. Okay, because you have to have 3 lines that look like they're parallel for this one to happen. You know, if you want to give yourself reminders there, I would do it. Okay? So right now, you should have on the list is those 4, and those 2 more. It doesn't matter the order of them. I just have 7 and 8 there. It doesn't matter. If you run the other way, it's good. The first 4 are your main ones, like I said, 5, 6, and then this last one that's going to be up there, are going to be just shortcuts or things that are very specific situations that have to be given to you, okay, that you can't use every single time. But the 1 through 4 are the main ones. These are things you're probably going to be looking for to start with. Okay? So if you want to remind yourself, for theorem 3.7, you have to have 3 lines. For theorem 3.8, you have to have perpendiculars given to you. You have to start with perpendicular lines. Consecutive and same side of the line. Just put it up. All right. Can I go past this?
Sure.
So, last theorem is this. This one's right from the book, so I'll actually use that to fill in. All right, this will be the last thing we do. There isn't much like big time example like. Okay, so with this one here, theorem 3.9, this one really doesn't need to go on the list because it doesn't talk about proving lines are parallel. You know, I'm sorry, I just said it was, but I forgot. It's the 7th way something. This one is just a way for you to quickly tie together 2 lines being perpendicular to the same line. Again, there's ways around this. And most of you guys are probably not going to be thinking in order of this theorem. It's just a shortcut if you can remember it. Alright? So for this one here, you have to know that you've got 2 parallel lines, and you have to have 1 line perpendicular. Okay, 1 set of lines being perpendicular. Alright, so if you fill in the 15 and 16 in that companion thing, you're kind of filling in the theorem. So Jazz, if you look at this one here, picture it's going. According to the way the theorem works, it says, if A and G are parallel, okay, and A and T are perpendicular, that means that this theorem says if you know all this to start with, this has to be given to you, all right, then you can say G and T are perpendicular without having to go like roundabout with much longer explanation. This theorem just allows you to skip right there. Okay, if you wanted to fill in 16 just so it matches up, this would be what? C and N, N and P, so. Okay, so your list right now should have 6 things. This one is just one other thing you might run into. You're probably not going to see it that much. So, honestly, remember I said, you know, if it's got a name, you're trying to remember it. I'm not going to really ever go with that name. It's awesome. Alright, it's not that big a deal to do. Alright, so